Welcome back to this playlist and greetings of the day, everybody. In this playlist, we are trying to solve numerical problems based on the concept of circular motion, as mentioned in the previous videos as well. The questions in this particular playlist have been obtained from the Cambridge publishers. The name of the author is K.A. Sokos. This is the 7th edition. The key to success in IB physics, guys, is about practicing as much as possible. This is a completely different scenario in comparison to the previous questions. In this specific question, we are trying to determine the cause of centripetal force. And we all know that centripetal force is not a force to be represented on the free body diagram. The centripetal force is in fact the net force acting on the body, which is responsible for the circular motion of the body. Now, in this particular scenario, as specified, the static friction might be playing the role of centripetal force. Let's try to observe that. It talks about a car moving on a road. All right, so this is the car. Kindly pardon my excellent artistic skills here. So this is the car. The mass of the car is 1100 kg. Now, if you look at the forces acting on this particular car, there is going to be an mg in the downward direction. Again, I will not be able to draw this to scale. So if this is the mg, that is the gravitational force, there is going to be a normal reaction as well. Now, I am going to show the normal reaction acting at two different points in this diagram. And the reason here is pretty simple. Normal reaction is that force which exists between the body wherever it is in contact with the surface. Therefore, in this particular diagram, since I'm showing you two wheels, I am showing two arrows as well as a normal reaction. And since there is no vertical movement of the body, we can safely say that the overall normal reaction here will be equal to the gravitational force acting on the body in the downward direction. Now, the only other force which is therefore responsible for the circular path, am I allowed to say, would be the static friction? From the formula booklet, or rather from the data booklet, we will be able to notice that the maximum possible static friction acting on a body is given by mu s into n, with mu s being the coefficient of static friction. Now, the reason why I am specifying that this is the maximum possible value of static friction is because as and when the applied force increases, the value of a static friction also will go on increasing until its value is equal to the limiting friction. So this particular value would be equal to the limiting friction. So Fs is equal to mu s into n. In this case, n can be written as m into g. So this is our static friction. Now the static friction will be playing the role of centripetal force. Therefore, Fs is equal to Fc, which is the centripetal force. Mu s into mg can then be written as mv squared upon r. Now, needless to mention, I will be able to strike off the mass and the mass on either sides, indicating that the mass of the body does not play a role in this particular scenario. Now, from this particular equation, we can now write v square to be equal to mu s into g into r. Alternatively, v can therefore be determined by the square root of mu s into g into r. What are the values provided to us here? The value of mu s is 0.70. So 0.70 into the value of a g would be 9.8, and the radius of the circular path that the car is negotiating, it is 95 meters. All right, so this will be the value of the maximum possible velocity of the car on that particular surface. Let's quickly try to calculate the values here. It is 0.7 into 9.8 into 95. and all of this under root will now give me a value of 25.52. So this is 25.52 meters per second. We need to remember that we will have to express the final result to the appropriate number of significant figures. The values given to us, 1100 has got two significant figures, 0.70 has got two significant figures, 95 also has two significant figures. Therefore, our final result here also should be expressed to two significant figures, which is now 26 meters per second. So the answer to the A bit would be 26 meters per second. Now let's try to solve the B bit here. It says in wet conditions, the coefficient of friction is reduced to 0.40, as is the case. I mean, whenever the road is wet, automatically the coefficient of friction would drop down. It would be easier to let a body slide on a wet surface than on a clear and dry surface. Now it says predict the safe maximum speed. Now we already have obtained a formula to determine the velocity or the speed with which a body can move along the circular path. Therefore, I can apply that formula directly. V is equal to square root of mu s into g into r. This will now give us mu s will be 0.4 into 9.8 into the radius of the circular path continues to be 95. Let's quickly solve this number here. The value, it is going to be 0.4 into 9.8 into 95 gives us 372.4. Square root of that would give us a 19.29. So 19.29, the maximum possible speed which the body can travel with on this dry surface, as you can notice, has actually dropped down from a 26 meters per second. Again, expressing it to the appropriate number of significant figures would give us 19 meters per second. There you go, guys. This is the final result for the B bit. Hope you understood this. Continue to follow, subscribe, like, and share. Thank you and goodbye.